Right, David. So far we've covered energy in and energy out, and the effects of humanity in terms of how we use energy, and global heating, understanding that a little bit more, and then the key process of feedback and amplification, which you illustrated very well with two everyday or possible everyday experiences, and then a little bit with the climate system itself. So what's the next key thing we need to understand here, do you think?
I think we understand climate change is made up of two real parts. Global heating comes from two sources.
Yeah.
There's the what we done, the release of carbon dioxide as a result of using yesterday's energy.
Yeah.
And then there's the amplification
Yeah.
of what we done by the feedback system that makes it worse.
Yeah.
So the real question is, the fundamental question is, by how much does our Earth, our planetary system, amplify the effects of carbon dioxide that we're putting out? Well, if we doubled the concentration of carbon dioxide from what it is, say, just before the Industrial Revolution, about 280 parts per million, remember that's how we measure it, put it up to about 560, I use my 2 times table with an occasional reference to a calculator these days, double the amount of carbon dioxide in the atmosphere, then the temperature would go up by about 1.2 degrees to compensate for the greenhouse effect if there were no feedbacks.
Right.
So the question is, by how much do the feedbacks amplify that 1.2 degrees?
Yes.
Now, this is where we end up running into problems. First of all, that amplification is what we call climate sensitivity. By how much does the system amplify the signal? The signal is carbon dioxide output.
So it's the sensitivity of the system.
The sensitivity of the system to the disturbance that we make.
Okay.
Spot on. We have some very, very sophisticated computer models of the climate system today. Cost many, many millions of pounds to program, and they run on supercomputers. They find it extremely difficult to model all the complexities of the feedback system, so they're conservative. They work with basic water vapor feedback, which we've just described, a bit of cloud feedback, more cloudy air reflects more light back into space, but also protects the Earth from radiation going outwards as well, so it keeps us warm. There's a double. Ice melt, as we said, decreases the amount of light reflected, so increases heating. Those 3 basic fast mechanisms or feedbacks which are included in most of the models. But there are many other feedbacks that are too complex to model at the moment. And I suppose the average outcome of the question, if you like, by how much amplification does the feedback system contribute, is a factor of about 2.5. So instead of 1.2 degrees, we would end up with 3 degrees, is the agreed consensus of computer modelers. The people who've been looking what we call the paleo records, the long history of Earth response to carbon dioxide change, say that seems to be far too conservative. And part of the work that I've done over the last 6 years is to use 4 different methodologies that are not based in computer modelling of the climate system, but are based in both mathematical calculations and in the observation and measurement of carbon dioxide and temperature as it has occurred historically. And we've come to a pretty clear consensus that the minimum sensitivity is around 7.8 degrees for the overall response of the planet to a doubling of carbon dioxide, not 3, as the computer models are telling us. And since our whole international negotiations are based on conservative computer models, we think we don't have too much of a problem. And actually it's underestimating by about 250% the severity of the situation we now face.
Incredible.
Absolutely devastating. So change in our understanding of climate sensitivity is right on the leading edge of climate science.
And actually, when you say we, are you saying the climate scientists in NASA or Max Planck or whatever? Who are actually?
Well, we.
Who are we? Yes.
That's difficult because, science has a huge range of disciplines, and people who work in what we call systems analysis will have a different approach to people who work in computer modelling.
Right.
I will not say there is a consensus in the scientific community because there isn't on this issue. There's a consensus, i.e. the best average figures are agreed around 3 degrees. If you look for a consensus, you'll look at that. If you take that as truth, you're in trouble because the consensus is always conservative.
Right.
And we need to know the reality of the crisis,
Right.
not the consensus view of the crisis. So the question is, what are the most competent analysts
Right.
saying
Yes.
in terms of the sensitivity of the Earth system to our disturbance that we have made to it? Now, I suppose I have to be very arrogant and say I think I am one of perhaps a group of 4 or 5 people in the world who are looking at this.
Yeah.
And the analysis that I'm presenting just in a few days' time, actually, for the 3rd Global Conference on Global Heating, Global Warming, which is occurring in Lisbon, in Portugal, will be the first public academic presentation of this material in a formal peer-reviewed context.
Right.
Unless we can falsify and fault that analysis, then we have to act on it.
And can you say who are the 3 or 4 others? Can you say, are they well-known names or people who are in well-known places?
Well-known to whom? Well-known within.
Yeah, but there's
I mean, there are people like Professor John Schellenhuber, who heads up the Potsdam Institute for Climate Impact Research,
right.
Who has been saying for a long time that we've already passed the limits of absorption of carbon dioxide in the atmosphere. There's Professor John Rockström from Sweden, who produced a paper with others, and I was involved to start with in that workshop as well, on the boundaries we shouldn't cross.
Yes.
And he's making the same comment. Perhaps the best known person is Professor James Hansen of NASA and Columbia University, who has been saying we're way past the concentration that is permissible.
So you're kind of been linking.
I'm in the envelope,
but
pulling this material together is a synthesis for the first time.
In correspondence with that.
Absolutely.
Would it be useful to talk about some of the effects of different degrees at this stage, or shall we go on to something else? Let's pause there anyway.